What's up, scholars? Today we're talking about area. We're going to talk about area in 2D and in 3D. Area in 3D is really called surface area. Okay, so we're going to base our 2D area discussion off of the area of triangles. So let's recall, what is the area of a triangle formula? Well, that is 1/2 base times height. And the height of a triangle is the length of the segment that makes a right angle with the base. So that's our height, and that's our base, and the area would be 1/2 the base times the height. Cool. So we're going to take regular pentagons. Let's remind ourselves what that means. Regular polygons. I am going to use a pentagon first. But regular polygons are called such because they have all their sides and all their angles are congruent. All sides and angles congruent. And we're going to split them up into triangles, and we'll use those triangles to figure out the area of the polygon. How cool is that? Very, very cool is what that is. So let's take a regular pentagon. Let's pretend that's regular, meaning all of these sides are congruent and all of these angles are congruent. And we're going to find the area of this regular pentagon using the triangles inside it. Okay, so we can split this pentagon into 5 triangles that are also the exact same shape and size, if your drawing was better than mine. So we've got 1, 2, 3, 4, 5 triangles. We could find the area of one triangle and multiply it by 5, and we'd have the area of this regular pentagon. So let's say, for example, the height of this little triangle, we're just going to look at this guy down here, just this guy down here. Let's say this height is 3 feet. Cool. And then let's say we know that the perimeter of the pentagon, the perimeter, the around measure, is 25 feet. So what does that mean? The perimeter is 25 feet. We have 5 sides that are all equal to each other. Each of these sides would be 5 feet exactly. We took 25 and divide by 5. So each of these sides is 5 feet. So now we have 5 triangles that have a height of 3 and a base of 5. So let's just look at the area of the triangle for right now. Let me redraw that picture. We've got a height that is 3. We've got a base that is 5. What would the area of this one triangle be? Well, we could use this formula. Area is 1/2 base times height. So we could say the area of this triangle is 1/2. The base is 5. The height is 3. That's 1/2 of 15, which is 7.5 feet squared, because we're talking about area. So one of these triangles has an area of 7.5 feet. How many of these triangles are there in this regular pentagon? Well, there's 5. So the area of the whole pentagon is going to equal the area of the triangle times the number of triangles. Area of triangle times number of triangles. So this is going to be 7.5 feet squared times, there are 1, 2, 3, 4, 5 triangles exactly the same shape. So 7.5 times 5 equals 7.5 times 2 is 15 times 2 is 30 plus another one, 37.5 feet squared. So what did we do here? We had a regular polygon. All the sides and angles are congruent. We can take any regular polygon and split it into triangles. There will be the same number of triangles as there are number of sides. So this guy was a pentagon, so it had 5 sides and consequently 5 triangles. We found the area of one of those triangles, and then we multiplied by the number of those triangles to find the area of the entire regular pentagon. Pretty sweet. Let's talk that through one more time. Now we're going to find the area of a regular hexagon, meaning it's got 6 sides and all of those sides are equal to each other. If it's got 6 sides, that means we have 6 triangles that are exactly the same. So we'll find the area of one of those triangles. We've got the height here, which is also, in this case, called the apothem. Apotheum. The apothem, which is the distance from the center of the polygon perpendicular to one side, but it's really the height of our triangle. So anyway, let's find the area of one of these triangles where the base is 7 and the height is 3.4. So the area of one triangle is 1/2 the base times the height is 1/2 7 times 3.4. Gonna have to bust out a calculator for this one. We've got 0.5 as a half times 7 times 3.4 is 11.9. That's the area of one of the triangles. And how many triangles do we have? We've got 6. It's a hexagon. There are 6 of these triangles that are exactly the same. So the area of the hexagon, our 6-sided figure, is going to be 6 times that 11.9, which we will get 71.4 units squared because it's area. Sweet. All right, that's all of our discussion of the 2D areas. Let's move on to 3 dimensions. All right, let's start talking about some surface areas. This guy right here is called a prism. Prism. Cool. Now, if we look at it, it's a 3D shape. Let's get some 3D lines going in there. These 2 sides are the same, like this front and back. Those are the same. The sides here, this one on the right and this guy here, would be the same. And the bottom and the top would be the same. So the surface area would be 2 times the area of this side. So let's put some dimensions here. Let's call this our height and our length and our width. Okay? So the surface area is going to be 2 times the area of this side, because that is both of these, the front and back. So 2 times LH plus, we're going to have 2 of these side rectangles, which are made up of H and W. W would be the same here, H, W, W. So we have 2 times HW plus 2 times, now we need the top and the bottom. And the top and the bottom are made up of L and W. So 2 times LW. All right, let's put some numbers in here, see if this makes a little bit more sense. Let's say our height is 3, our length is 4, and our width is 5. What would the surface area, and let's call these feet. Feet. So the surface area of this prism is going to be 2 times the area of the front side, right? Because that's the front and the back. So the area of this front side is 3 times 4, which is 12, plus 2 times the area of these sides, which have a height of 3 and a width of 5. 3 times 5 is 15, plus 2 times, now we want the top and the bottom. Top and bottom are made up of this side that's 4 units long, or 4 feet, and then 5 feet. So we've got 4 times 5 is 20. So 2 times 12 is 24, plus 2 times 15 is 30, plus 2 times 20 is 40. If we add all of those up, the total surface area of this prism is 94 feet squared. Cool. All right, be careful. Don't do the volume here. Don't do length times width times height. All right, we want the surface area. We want the area of all of the sides. Add it up. Now this guy is called a cylinder. All right, it's like a can of soup. Let's think about this for a second. It has 2 circles. So we know if we're talking about the surface area, we're going to want the area of these 2 circles. So we've got 2 times the area of a circle, which is pi r squared, where r is the radius. So that takes care of our 2 circles. And then we want the area of this chunk that goes all the way around. So this part that goes all the way around the circle, right? The rest of this, like the front of the can, all the way around. That's going to be the circumference of this circle times the height. The circumference of the circle times the height. The circumference of a circle is 2 pi r times the height. So that'll be the surface area of our cylinder. Let's put some numbers in, make this make sense. Let's call this 10 meters, and our radius, let's say, is 2 meters. What would the surface area of this cylinder be? Well, 2 pi r squared means 2 times pi times our r, which is 2 squared, plus 2 times pi times r, which is 2, times h, which is 10. Just plugging in these numbers. So we get our surface area is, what do we do first here? Our exponent. So we got to do 2 times 2, or sorry, well it is 2 times 2, but 2 squared, 4. 4 times 2 is 8, so we have 8 pi, plus 2 times 2 is 4, times 10 is 40 pi. We can add those together to get 48 pi meters squared. This could be your answer. Leaving pi in your answer is awesome. It's prettier. There's no decimals. But you might be asked to plug in 3.14 as pi. Then you'd get 150.72. 150.72 meters squared as your answer. Beautiful. Alright, next up we got this guy, which is a triangular prism. Triangular prism. Whoop. Okay, so let's look at this for a second. We have 2 triangles that are congruent. So our surface area is going to be 2 times the area of these triangles. Plus, we've got this front side here. Alright, the front side here, the back side here, and this bottom base. So we've got 2 triangles. We've got a front, like sloped side, back side, bottom side. Slope plus back plus base. Let's call it. That'll be our base. Alright, so we're going to need some numbers here. So let's say this side is 2 inches, this will be 3 inches, this will be 4 inches, and this will be 5 inches. Great. Alright, so our surface area, 2 of the triangles, right, we have 2 surfaces that are triangles, so we need 2 areas, or 2 times the area of that triangle. So 2 times the area of that triangle is 1/2 times the base of that triangle is 3, the height of that triangle is 4, 1/2 times 3 times 4, so those are our 2 triangle areas. Plus, we need the area of this sloped side, which is 2 times 5, which is 10. Plus, we need the area of the back, which is 2 times, how long is that side? Well, that's the same as that side, so 4 times 2, which is 8. I probably could have just written 8. And then the base here is 2 times 3, which is 6. Okay, so our surface area. 2 triangles. Those were 1/2 base times height, which were 1/2 times 3 times 4. So 2 times 1/2 is 1. So it's 12 plus 10 plus 8 plus 6 equals 12, and 8 is 20 plus 10 is 30. So 36 inches squared is the surface area of this entire triangular prism. Sweet. All right, the last one I'm going to squeeze in up here. This is, of course, the mighty sphere. Area of a sphere is, the surface area of the sphere is 4 pi r squared. That r stands for the radius, so let's call this guy 8 meters. And find the surface area of the sphere by plugging into 4 pi r squared. So 4 times pi times 8 squared. 8 squared is 64. 64 times 4 is 128 times 2 is 256. Is that right? 256. Yes, perfect. So the surface area is 256 pi meters squared. We could leave our answer like that. I think that's the prettiest. That's the exact answer. There's no rounding that was involved because we didn't round what pi was. But if we needed a decimal answer times 3.14, it's going to get us 803.84 meters squared. Those are our two options. Okay, so we talked about finding the area of a 2D shape, specifically a regular polygon, by breaking it up into little triangles and multiplying the area of that one triangle times the number of triangles, which will be the same as the number of sides, to find the area of that regular polygon. Then we talked about surface area of 3D stuff. We got a prism, we got a cylinder, we got a triangular prism, we got a sphere. Excellent, beautiful, wonderful. And I am going to plug that if you're getting bogged down with these calculations, Google the words surface area calculator. It'll bring some stuff up. Use that to help you check your answers. All right, that's it. Love you, scholars. See you next time. Keep on that hustle.